Hello everyone. Just a minute. Hi everyone. Sorry for that noise interruption. Um, oh, I don't think it's from my side. I think it's from your side, Steven. Welcome to the Africa STEM Summit. We have Steve Ongati, who will take us through front-end development best practices for software developers, for senior developers. Steve, take over. So yes, because you're started slightly late, Steve, you can kindly take over. Thank you.
Okay, thanks for this chance. My name is Steve Ongati. I'm a software developer. So today we are going to talk about front-end best practices that are recommended for the software development in the market. So the first thing we will start with is to know what is front-end development and what are the best practices that are required in the market. So first, front-end development plays a crucial role in web applications as it is directly interacts with users. So providing the visual and interactive elements that make a website or a web application engaging and user-friendly. So basically that's what front-end development does, or what a front-end developer should do to make a website user-friendly, interactive, and implement the elements that will enable the user to interact with the web page friendly. So the front end, the front end development is responsible for creating the user interface, handling users' interaction, and presenting data in a meaningful way. So a well-executed front end is essential for delivering a smooth and enjoyable user experience, which is paramount for the success of any web application. So if we have a good user interface to our client, the web application or the site will have more visit and more friendly interaction with the client because the user interface is more friendly and more interactive to its users. So in front end development, there are some things that we consider that are best practices for a front end developer to know and to interact with. So the first thing we do, you have code organization and structure. Those are the most important things that as a front end developer you should be able to know when starting. So a web application grows in complexity. Maintaining, cleaning, modular, and easy maintenance, code becomes increasingly vital. So when you have a well-organized and well-structured code in your web application, when let's say we have developed a web application and you are a front-end developer. So if you develop that website today or that front-end today, you might not stay in that company or on that organization for the whole of your life. But when you develop a clean and well-organized code, if another developer comes to check on that code, it will be easier for him or her to debug or maintain the code because your code is well organized, well maintained, and it is organized in some modules that it will enable him or her to debug the web application. So that's why the main things that we consider is code organization and structure. Code organization and structure. So the structure, you may decide to use modules to organize your code, or you may decide to use components. That's how you structure your codes to make it easy for maintaining, cleaning, and so on and so forth. So a well-organized code improves collaboration among developers. So when your code is well organized, it will improve collaboration among developers, allows for easier debugging, and facilitates future enhancement and updates, as I said earlier. So it will enhance good good coding practices where if another developer can come in future to update the system or the front end or the user interface, it will be easier for him to update. Then another thing it enables teams to work efficiently, minimize development errors, and helps ensure consistency across the application. So, so proper code structure also enhances code readability, making it easier for developers to understand and navigate and modify their code base. So if you make a proper code structure, let's say you have structured your code in modular form. So if you structure your code in modular form or feature-based form, it will be easier for another developer if you are collaborating making the same website. If it comes to that code, it will be easier for him or her to go through the code and understand the code easily than writing your code mixed up, not having a certain structure where some other developer can understand this is how the code flows, this is how each and every functionality works. So we need a code that is code readable, that is the readability of the code is very easy to other developers. So on today's session, we are going to have some few best practices or techniques that we need to know about front-end development. So the first thing will be doing is structure approach to code organization. And then the second thing we'll be having is separation of concerns. And then we have utilization of component-based architecture, and then optimizing performance, implementing testing, readability, and maintainability. Then you have performance optimization, loading and code splitting, optimizing images and assets. Then finally we will talk on the importance of testing in front-end development. So if we start by our first best practice, which is code structure and organization. So when it comes to front-end development, establishing a well thought out file and folder structure is essential for maintaining a clean and organized code base. A clear structure not only enhances collaboration. So when you structure your files in front end, so let's say we are creating a website and we have some functionalities that we want to implement. So in our code, we need to have each and every functionality. We might decide to create a file for each. Let's say we create an HTML file for let's say a functionality like the login. So we create a file for the login page, and then we should have its own file for styling. Let's say we have CSS, we create a file for CSS where we'll enable us to style that file for HTML to enable it to have some certain styling and appealing features. And then if we want to improve on that feature of the login to have more functionalities, that's where we bring in JavaScript. So also JavaScript will create a certain file for the JavaScript. Then as we continue, a clear structure not only enhance collaboration and efficiency among developers, but also simplifies maintenance and future updates. So if you have a clear structure of your front end code, like let's say you have your CSS, CSS is encrypted in a certain folder, JavaScript in its own folder, debugging and making changes or updates will be easier compared when you have your code mixed up in one file. Let's say there's some developers who use, let's say you have created an HTML file, they will always use CSS, JavaScript on the same file without separating. So it becomes so difficult for some developers to come and navigate through the file, start debugging, cleaning the code. But if you separate each and every structure of the code, it will be easier for cleaning up, maintaining, and debugging. So there are some considerations that we need to consider when creating an effective file and folder structure. So the first one, benefits of a clear and logical structure. That's the first consideration, benefit of a clear and logical structure. So what do we mean by saying benefits of a clear and logical structure? So a well-organized structure improves code readability and reduces the cognitive load on developers. So if you structure your files and folders, it will be easier for the code readability and reduces the cognitive load on developers. So if I develop an application, if I'm doing, let's say, a certain feature on the about page, I'll only concentrate on the about page, and the other developer will concentrate, let's say, on the authentication page. So if you are concentrating on the about page and the other developer is concentrating on the authentication page, if I try to go and read the code for the authentication page, I will be able to understand the code because it is structured on its own file. And if the other developer or the other software developer decides to come and read on my other file, he will find the code structure is well structured and well organized without having any mismatch. So that's why we recommend a clear and logical structure, which is by separating each and every file or each and every functionality for easier code readability. Then the second one, we have commonly used structures. So we have two commonly used structures that enables a good arrangement of codes. So the first one is component based. The first one is component based structure. So on this approach organizes code around reusable components. Each component has its own folder containing the necessary HTML, CSS, and JavaScript files, as I said earlier. So each folder contains the necessary HTML, CSS, and JavaScript. So you can have a folder, let's say you can have an HTML file. You can have a folder that contains the HTML file. Then you have another folder that contains the CSS files, and then another folder that contains the JavaScript file. This will enable us to separate our code so that we can make them easier to debug, clean, update by separating them in different folders in their own files. So this code-based structure promotes code reusability, simplifies maintenance, and facilitates the testing of individual components. As I said, it will help us so that we can test individual components of our code structure. So if we say we have a certain feature, like we have a form, we want to test that form. So it will be easier for us to test the form because the code will be structured in a component-based structure where each and every functionality is separated. And then the second the second approach is feature-based structure. Feature-based structure. In this approach, code is organized based on application features or modules. So in the application, if we have several features, let's say we have a feature where, let's say we are making an e-commerce website. So we have a feature where to add to cart. We have a feature where we want to add stock to the system. So each feature should be separated and be coded individually so that it will be easier for the other developer to read and understand what does this module or this feature does, or what does this module that has been written in this file does. Each feature has its own folder containing all the related files. So each feature has its own file that contains all related files, including HTML, CSS, and JavaScript. So if you have a cart feature where we add our products to the cart, it should have its own HTML, CSS, and JavaScript. This structure helps in better separation of concern and enables teams to work on different features independently. So each developer can work on different features independently by separating the concerns. So I remember I told you we'll look at the separation of concerns. So separation of concerns is where we separate each and every action that is being done by developers who are collaborating. Let's say someone is working on a card, someone is working on the product side of it. So each and every person will do its own functionality, and then they will be merged to get together. So that's you are under the creating effective files and folders. So another consideration that we should consider, grouping files by functionality or modules. So it is important to group related files together to enhance code organization and maintainability. For instance, CSS files for a specific component or module can be placed in the same folder, ensuring that styles are easily located and updated. So let's say we want to create a landing page. So our landing page should have some, let's say, some carousel where pictures are moving. Yeah. Sorry for the interruption. So we were talking about the grouping files by functionality and module. It is important to group related files together to enhance code organization and maintainability. For instance, CSS files for a specific component or module can be placed in the same folder. So, as I was saying, let's say we have a landing page that we want to create that contains a carousel. So that's where I came in and told you we can have an HTML where we write our code for the same, and then we have a CSS which will enable us to style that landing page to enable that carousel to have the moving effect effectively. Then, so by organizing files and folders based on functionality or module, Developers can easily navigate to the code base, minimize conflict, and reduce the chances of introducing errors when modifying or extending the application. Adopting a thoughtful file and folder structure is a fundamental step in front-end development, and it sets the foundation for a well-organized code base, improving collaboration and contribution to the overall efficiency and maintenance of the project. Then we go to the next best practice, which is separation of concerns. So in front-end development, the separation of concerns principle is a fundamental concept that emphasizes the division of code into distinct parts, each responsible for a specific aspect of the application. This principle promotes modularity, maintainability, reusability of code. So when we separate concerns, so what do we mean by this? This is where we want to separate each functionality to be done independently. So if one developer is working on this functionality, the other developer should be working on this functionality. So we separate so that once all the functionalities are done, they can be combined together. So we have some key considerations on the separation of concern. So the first consideration that we look at is the role of HTML, CSS, and JavaScript files. So in a typical web application, HTML defines the structure and content, CSS handles the presentation and styling, and the JavaScript provides interactivity and behavior. By keeping these three layers separate, it becomes easy to understand, modify, and maintain each aspect of the application. Self-explanatory, as I just said. Then we have another consideration, keeping markup styles and script separate. So separating HTML, CSS, and JavaScript codes allows front-end developers to focus on their respective domains. The markup, which is HTML, should primarily define the structure and semantics of the content, while CSS should handle the visual presentation and layout. JavaScript, on the other side, handles the behavior responsibility and the dynamic interaction, also event handling and data manipulation. So that's the second consideration that we should have. Then the third one, importance of module and reusable code. So module code is divided into smaller and self-contained units that perform specific tasks. So this approach makes code easier to understand, test, and maintain. By breaking down functionality into smaller modules and components, developers can focus on individual pieces of code and make them reusable according to the application. So that's why it is advisable for developers, when you are developing an application, use modules. Modules is like breaking down a huge chunk of work into small pieces that can be solved independently. So if you have a certain functionality, you can break it into small modules so that it can be easier to do that work. Then reusability saves development time and effort. An existing component can be leveraged to build the new features of pages. It also promotes consistency and reduce code duplication, leading to more maintainable and scalable application. So if you break down your code into modules, it will enable you not to have a redundancy. Redundancy is duplication of code. So you might have written a code and then you go to a certain place and then you repeat the same code. So you'll have some redundancy or duplication of code. Then, so adhering to the principle of separation of concern promotes code clarity, maintainability, and reusability. It enables developers to work efficiently, collaborate effectively, and enhance different aspects of the application without disrupting other parties. So by keeping HTML, CSS, and JavaScript separate and ensuring module code, front-end developers can create robust and existable applications that are easier to maintain and evolve over time. So if we use the separation of concern, our web applications will be very neat. And then if another developer comes like 20 years from now, you will be able to maintain that application, debug, you can be able to update it by using that separations of concern because the code will be easier to read over it. Then we go to the next best practice, which is component-based architecture. Component-based architecture. So under component-based architecture is a popular approach in front-end development that promotes modularity, reusability, and maintainability. So it promotes modularity, reusability, and maintainability. So modularity, we said, is breaking down our features or components into smaller units that you can solve. And then reusability is writing codes that we can reuse time, time to come. And then we have maintainability is where, let's say, we want to change some features or we want to clean our code. So the code should be clean or easier for maintainability. So under component-based structure, it involves breaking down the user interface into self-contained, reusable components, each responsible for its own functionality and appearance. So we have some aspects to consider when adopting component-based architecture. So the first aspect that we consider, definition and benefits of component-based development. So in component-based development, the user interface is built as a composition of independent and reusable components. Each component encapsulates its own logic, style, markup, making it self-contained and easily portable. So the benefit of component-based architecture includes improved code organization, easy maintenance, and reusability. So this also applied. This also is the same as the other best practices that we have talked about. So the main thing on this is code organization, easy maintenance, and reusability. So basically, in front-end development, we need to have a code that can be easily maintained, easily be reusable, and can be updated easily. So, like when we write codes, we use comments. So, comments can enable a developer to see this code does a certain functionality. Then, the second consideration that we have is organizing components into an hierarchy. So, components can be organized hierarchically, forming a tree-like structure. A parent component can contain child components, and those child components can have their own child components, creating a clear hierarchy of dependency. This hierarchy facilitates communication and data flow between components, allowing for more complex and interactivity. So if you have a parent component, and then you have a child component, and that child component has its own child. So the communication flow will be easier. So the communication will come from the parent component to the child component, and then from the child component to the other child component to the child. So by organizing components hierarchically, developers can easily understand the structure of the application, identify relationship between components, modify without impacting unrelated parts of the application. So That's basically on the organizing components into hierarchy. Then we have another consideration, communication between components. So communication between components within a component-based architecture often need to communicate with each other. So this communication can be achieved through various mechanisms. So we have pros, events, and then we have state management. So under pros, components can receive data and configuration through pros, which are passed down from parent components. Pros allows for one-way data flow, enabling parent components to control behavior, appearance of child component. So the flow will come from the parent component to the child component, and so on and so forth. So the flow will be very effective, and it will be one-way data flow. Then we have another mechanism which is event. So under events, child components can communicate with parent component by emitting event. The parent component listens for these events and responds accordingly, allowing for interactive and dynamic behavior. So if I explain it in a layman's language, so let's say a child tells a parent, I need this and this. So the parent will listen to the child, and then will make a decision from the information you get. So that's why you have the parent component listen for this event and responds accordingly, allowing for interactive and dynamic behavior. So that's how then we have the last one, which is state management. So components often need to maintain and manage their internal state. State management libraries or patterns such as the React state or Redux can be utilized by handling shear state or complex state management scenarios across the multiple components. So the same thing applies to component-based architecture. So component-based architecture also promotes code reusability, maintainability, and scalability. So by breaking down the user interface into module and reusable components, developers can build complex application with ease. And also it allows for effective collaboration among team members, as components can be developed and tested independently. And then what I can add on hierarchical structure. So hierarchical structure and the hierarchical structure and communication mechanism between components facilitates the development of interactive and dynamic user interfaces. Then we have another best practice that we'll talk about after separation of concern and then component-based architecture. So we'll go to code readability and maintainability. So ensuring code readability and maintainability is crucial for long-term success in front-end development. Code that is easy to read and understand not only benefit the original developers, but also facilitate collaboration, debugging, and future updates. So if you have a good code that is written, it will enable the system to have a good flow. And then if you have another developer who has come in who is new, you can be able to understand the code, read the code, and then you can be able to debug in case there is any debugging that is needed or future updates that can be needed in the system. So code readability and maintainability is very essential. So there are some best practices under code readability that we need to know. So the first one is consistent formatting and naming conversions. So consistency in coding, formatting, and naming conversion is essential for readability. Following a consistent style guide improves code comprehension and makes it easier for multiple developers to work on the same code base consistently consistent indentation, spacing, and naming conversion for variables, functions, and component create a uniform and coherent code structure. So, consistent formatting and naming conversion helps in consistent indentation. So, if you have a good indentation of your code, spacing, and then naming conversions for variables, it would be very easy for another developer to read through the code, debug it, or make any changes that may be required. Then another practice that is use of comments and documentation. This is common. So well-placed comments and documentation are invaluable for understanding complex logic, explaining the purpose of code sections, and providing instruction for future modifications. Comments should be used sparingly but effectively to provide clarity and context where necessary. Additionally, maintaining up-to-date documentation such as README files or inline code comments helps new developers quickly understand their code base and make informed contribution. So it is advisable when developing a web application, you should have a well-documented README. So a well-documented README should contain the most basics that a developer or someone who is not a developer can understand what does that web application does. So let's say you have a README that explains this is the web application, this is what it does. So and then you'll have where you have written the technology you have used, and then you have indicated how you can run that system to run in your machine. So there are some guides that you give. So a well-documented README will enable another developer to understand well the system than coming, let's say he comes and then finds that you don't have a README for that web application. So it will be somehow difficult for him to start running through the code, start reading. But if you have a README, it will guide him, or a well-documented code which has some comments that specify this does this. It will be so helpful. Then you have another practice which is breaking down complex code into smaller functions or modules. So breaking down complex logic into smaller reusable function or modules improves code maintainability, readability. So by dividing complex tasks into smaller self-contained unit, code becomes easier to understand, test, and modify. Then, yeah, basically those are the main aspects in code readability and maintainability. Then we have performance optimization under the best practices for front-end development, performance optimization. So in front-end development, performance optimization is a critical aspect that directly impacts the user experience and the success of web applications. Optimizing the performance of a website or web application involves implementing techniques and strategies to ensure fast loading times, efficient resource utilization, and smooth user interaction. By prioritizing performance, developers can deliver a snappy, responsive, and enjoyable experience for users across various devices and network conditions. This section will explore several key areas of performance. So, under performance optimization, this is where the developers must look at how will that web application perform and how will it be responsive and the experience for the application to the user. So where that is where the developer comes in and looks at the user interface from a point of a user who does not know how a website that is responsive, how it should look, how it should appear on the phone. So that's the other practice that a developer should look at. So also performance, we look it in a way that the loading of the application, when a user loads the application, how long does it take to load? When the user, let's say, downloads something from the application, how long does it take to download? So that's that's said and done. So under this performance optimization, we look at two main considerations that must be looked at. So we will look at two techniques. So we have minification and bundling, which helps it to reduce file size, lazy loading, and code splitting to optimize resource loading, optimize images and assets, and implementing caching strategies. So under minification and bundling, so we have a significant factor affecting web application performance is the size of the files that need to be downloaded by the client's browser. Larger files take longer to load, especially on slower internet connection or mobile devices. So minification and bundling are two techniques used to reduce the size of front-end assets such as HTML, CSS, JavaScript, and optimize the delivery to the user browser. So what is minification? If you may be asked, what is minification? So minification is the process of removing unnecessary character from code without altering its functionality. So there are some characters in our code that are not usable. If we remove them, our code will function as it was intended, but the functionality will not be altered. So these unnecessary characters include white space. So we have a lot of white space in our web application. Comments, so we have unnecessary comments, and sometimes long variable names. So you get someone writing a variable name that has, let's say, variable name that contains 5 words. So those are some of the things that make the web application to be slow. By reducing the size of the code, minification helps in speeding up the loading time of web pages and improving overall performance. Minification can be done manually, but it is more commonly automated using various tools and build systems. So we can do it manually, but we have tools that have been built to do that work. So popular JavaScript minification tool includes Uglify.js, and then we have Tisa. While CSS minification can be achieved using tools like Clean CSS, HTML minification can be performed by tools such as HTML minifier. So these tools ensure that the code is minified without introducing any errors, allowing developers to focus on writing clean and readable code. So that's under minification. Then we have bundling. So in modern web development, web applications are often built using multiple JavaScript files, each containing different functionality or modules. While this modules approach is beneficial during development, it can lead to higher numbers of requests to the server when loading the application in the browser. So bundles comes in here. So bundling addresses this issue by combining multiple files into a single file, reducing the number of HTTP requests required to load the application. Bundling tools such as Webpack and Rollup analyzes the dependence between JavaScript files and creates a single optimized bundle that includes all the required code. So this will reduce the requests that are running on the JavaScript files. So in addition to reducing HTTP requests, bundling also enables better compression and caching of resources, further improving loading times for the returning users. So when you visit a web application and then you find it takes long to load, so there are a lot of requests that are being requested, hence making it to take a lot of time to load. So this is where we come up with the bundling aspect of it, and then we install the Webpack and the rollup tools, which will compress the JavaScript files and then make it easier for loading. Then we have benefits of minification and bundling. Benefits of minification and bundling. So minification and bundling offer several significant benefits for front-end performance optimization. So the first one, faster loading times. So this is faster loading time is self-explanatory. By reducing the size of assets, minification and bundling speed up the download process for end users, resulting in a quicker page load times and more responsive application. So the website or the page will load faster. The downloading will take a little bit slower time compared to the previous one. So that's the first significance of the benefit. Then the second one, low bandwidth usage. Smaller file size reduces the amount of data that needs to be transferred from the server to the client, saving bandwidth and potentially lowering hosting cost. So we reduce the bandwidth usage. So smaller files will reduce the amount of data that needs to be transferred. So if we had a file that is like 1 GB and then it is compressed to a storage of, let's say, 500 MB, so it will reduce the storage, and then it will reduce the size, and then the amount of data needs to be transferred from the server to the client will be reduced. Then we have another significant, which is improved caching efficiency. So bundling allows for better caching, as a single optimized bundle is less likely to change frequently, leading to more efficient use of browser and server caching mechanism. Then we have the last one, simplified deployment. A single bundled file is easier to manage and deploy, streamlining the development workflow and reducing the chances of errors during deployment. So if you have a smaller files application, it will be easier for you to deploy it. So hence reducing errors during deployment. So like, let's say you have done an application using Django. So during deployment, there are a lot of dependencies that you need to install. So if you install those dependencies and then you have a code that has a lot of code, you are likely to have errors occurring during deployment, and hence leading to the web application or the project not displaying. So by incorporating minification and bundling into the front-end development process, developers can significantly enhance the performance of web applications, providing users with a smoother and more enjoyable experience. So that's all on the part of minification and bundling, which is under performance optimization. So the next thing we look at is lazy loading and code splitting. So lazy loading and code splitting are techniques used to optimize the loading of assets in web application. They allow for a more efficient allocation of resources by deferring the loading of non-critical content and splitting the code into smaller, manageable chunks. This technique can greatly improve initial page load times and overall performance. So that's basically under lazy loading and code splitting. So splitting code into smaller chunks for fast faster initial load. So code splitting involves breaking down the application's JavaScript code base into smaller, more manageable chunks, which are then loaded dynamically as needed. Instead of delivering the entire JavaScript bundle upfront, code splitting allows for the selective loading of code that is relevant to the current page and user. So that's why we recommend modular or component writing of code. So if you use modules, the code will be broken down into small pieces or small chunks that will enable us to make the loading more easier. Then we have another best practice that is essential: optimizing images and assets. Optimizing images and assets. So efficiently optimizing images and other static assets is crucial for improving the performance of web application by reducing file size, utilizing appropriate images formats, and implementing effective caching strategies. Developers can ensure faster loading times and smoother user experience. So how does this work? So let's say we want to put some images on our web application. So it is advisable not to use links of images, like you go and pick copy a link and then use it as an image. But you can download those images and then store them in a folder in your application, where the images will be fetched directly from the folder that is inside your web application than taking a link like a, let's say when you use Bootstrap. You can use Bootstrap locally by by using the Bootstrap files that you download, and then you can use CDN links. So it is preferred you use it locally than using the CDN links, because it will make your website to have loading problems. Let's say you access the website, the images are not loading well. So basically, that's how optimization of images and assets work. So the first consideration that we take under optimization of images and assets is reducing image size through compressing technique. So images often ac- account for a significant portion of web pages file size. One effective method to optimize images is through compression. Image compression technique reduces file size without significantly impacting visual quality. There are two primary types of images compression. So we have loosey compression and then we have lossless compression. So this technique, the loosey compression, this technique achieves higher compression ratio by discarding some data that is less noticeable to the human eye. Loosey compression is commonly used for photographic images and can significantly reduce file size while maintaining acceptable visual quality. And then we have lossless compression. Unlike loosey compression, lossless compression reduces file size without sac- sacrificing any image data. It is ideal for images with sharp edges, text, illustration, where preserving fine details is crucial. So we reduce the size of that image, but we will not alter with any data on the image. So we have various tools and libraries such as Image Optim, Thin PNG, or the Image Magic library can be used to compress images effectively. Then under optimization of image, you have using appropriate image formats like SVG or WebB. So SVG is scalable vector graphics. And then WebB is a modern image format developed by Google that provides superior compression compared to formats like JPEG and PNG. Then let's talk about testing and quality assurance. So testing and quality assurance are critical aspects of front-end development that ensures the rel- reliability, functionality, and user experience of web application. So comprehensive testing practice help identify and rectify bugs, errors, and usability issues, ensuring that the application functions are intended across different devices, browsers, and user scenarios. So testing of web application enables us to remove some bugs or errors that we never recognized while developing the web application. So on the front end part of the application. So if we test each and every feature, we'll be able to know where we have errors, we rectify them, where we have bugs, we rectify them, and then we make the code so clean and reusable. So we have various testing methodologies and practices that front-end developers can employ to ensure the quality and robustness of their code. So the the common one that we have is unit testing, integration testing, and end-to-end testing, as well as we have unit testing, integration testing, and end-to-end testing. So those are the main testing that we have in our front-end development that enables us to test the features, the integration, and the end-to-end, how the functionality of the website work from this point to the other point. So by implementing a robust testing and quality assurance strategy, developers can detect and address issues earlier in development cycle, leading to improved stability, usability, and overall user satisfactions. So what's the importance of testing in front-end development? So testing plays a very crucial role in front-end development by ensuring the reliability, functionality, and user experience of web application. It is a proactive approach that helps identify potential issues, bugs, and errors earlier in the development process, leading to higher quality code and more seamless and end user experience. So this will enable us to see each and every functionality, whether it achieves the recommended or the required end goal. So that's why we do the testing so that we can be able to to ascertain that each and every functionality is working according to the function that it was intended to do. So at the end of this presentation, I'll work on a front-end development project, and then I'll explain it detail to detail, and then I will share the link of the video recording. Then it will be uploaded on the YouTube so that you can see the each and every step on how this testing occurs in front-end development. So the importance of testing, the first one, bug identification and prevention, enhanced user experience, code stability and maintainability, improved development efficiency, robust cross-browser and cross-device compatibility, compliance with accessibility standards. So, so those are the some of the best practices that that we need to know as front-end developers for a start. So I think for today we'll stop there. So in case of any question you can ask. Stella? I think for today we'll stop there. So in case of any inquiry or any question, you can reach out. You can reach out to my email, ngatikebas@gmail.com, or you can check me at LinkedIn at Steve Ongati. Thank you for the time and the session. Have a nice day.